This is SpaceTime Series 27, Episode 123, for broadcast on the 11th of October 2024. Coming up on SpaceTime, discovery of a new region within the Earth's core, fresh questions about the true origins of the Earth's moon, and a new study has revealed more secrets about Pluto's binary partner Charon. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Scientists have detected a new donut-shaped region within the Earth's molten liquid outer core. The strange torus-like zone was found at low latitudes parallel to the equator, right on the core mantle boundary. The Earth has two core layers, the inner core, a solid layer, and the outer core, a liquid layer. The outer core is predominantly made of liquid iron and nickel, and the vigorous movement of the electrically conductive liquid creates Earth's magnetic field. That's important because it shields the planet and helps sustain all life, protecting it from damaging solar winds and harmful radiation. Surrounding the Earth's core is the planet's mantle. It makes up some 80% of the total mass of the Earth, and sitting on the top of that is a very thin layer called the crust. That's where we live. A report in the journal Science Advances suggests that this donut region could be several hundred kilometres thick. One of the study's authors, Hudavia Kalzic from the Australian National University, says the region was discovered because seismic waves are travelling slower through this area than the rest of the liquid outer core. The discovery was achieved because rather than using traditional seismic wave observation techniques and thereby observing signals generated by earthquakes within the first hour of an event, the study's authors instead analysed the similarities between waveforms many hours after the earthquake's origin times, leading them to make this unique discovery. By understanding the geometry of the paths of these waves and how they traverse the outer core's volume, they were able to reconstruct their travel times through the Earth, demonstrating that the newly discovered region has low seismic speeds. This low velocity within the liquid core implies that there's a high concentration of light chemical elements in this region. It's that which could be causing the seismic waves to slow down. And these light elements, along with temperature differences, are also helping to stir liquid within the outer core. There are still mysteries about the Earth's outer core that are yet to be solved, and these will require multidisciplinary efforts from seismology, mineral physics, geomagnetism, and geodynamics. Kalzic says knowing more about the Earth's outer core's composition, including the light chemical elements there, will be fundamental to understanding the planet's magnetic field and predicting when it could weaken or cease completely.
In this work, we developed a new method, or at least we used a recently established method in seismology that looks in the late part of the seismic waveforms rather than the early parts that are probably well known to your listeners as compressional waves and shear waves. So here we are looking at the late part of the waveforms, and what's special about them is that they see the Earth in an unprecedented way because they are highly reverberating waves from the internal structures and the discontinuities. So by using that, we were able to peek into some of the secrets of the Earth that we were not able to understand before. And secondly, we then focused on the Earth's outer core, so the liquid core, and we were able to constrain a low latitude or equatorial, if you want, ring, or mathematically speaking, torus in the liquid outer core, with low seismic velocities lower than the surrounding outer core. The outer core is a liquid, right? So it's a hot ball of iron and nickel exposed to extremely high temperatures and pressures. So it's liquid, and if you think about the way the liquid outer core convects or flows, it's much faster than the mantle of the Earth. So it is liquid, and the reason why we were able to look into it is that the compressional waves spread through liquids, unlike shear waves.
Are we thinking this is made out of the same substance, the same molten iron nickel material as the outer core, or is this sort of a mixture between the outer core and lots of olivine and that from the mantle?
We are seismologists, right? So we use a geophysical inference based on our observations that we have on the Earth's surface. So we read a lot of waveforms, and based on that, we make some inferences about the deep interior of the Earth. And what we can conclude based on our studies is that the top of the liquid outer core is slower than the surrounding core, but not everywhere. It's only in the equatorial part of the liquid core. And then we can make some interpretations why the seismic waves slow down in that particular ring or torus in the liquid core. And our interpretation is based on some previous studies on the topic from geodynamics and geodynamical simulations, is that the origin of this low velocity ring must be thermochemical, meaning that it cannot be just due to the different patterns of liquid flow or convection in the outer core, and that it has to be due to a likely presence of a light chemical element in the liquid core that are for some reason concentrated in the equatorial torus. So those light elements, together with the different modes of convection, could produce a drop in the seismic velocity, yet not exactly what we observed. 2% is a quite large drop in seismic velocities, and it would require several order of magnitude difference in the density of the liquid core. So I would say this interpretation is still quite open to many scientists who study the dynamics of the Earth's interior to look into it and to demonstrate how it is possible to get such a dramatic drop in seismic velocities in the liquid core. Is it due to the presence of light elements, or perhaps due to a stratification that occurs at the ceiling of the liquid core, or a chemical reaction between the chemical elements of the liquid core with the metallic core with the silicate mantle? We don't know that yet, to be honest.
So as the Earth spins, it acts like a giant centrifuge, so different elements are separating, I guess, and we know that the composition's different. Is that because of the centrifugal effect, or is that simply because the core is slowly solidifying and this part hasn't solidified yet?
Well, the answer is probably a combination of all these effects. I should clarify that as the inner core solidifies, so as the Earth cools down, the temperature drops to a certain point at pressure, the inner core starts solidifying from the center outwards. And in the process of the solidification, we have, first of all, some latent heat that is released. And secondly, light chemical elements are released also in the liquid outer core. And there are some studies suggesting that it is possible to get both cylindrical flow that would be parallel to the rotation axis of the Earth, and that's how we think the flow in the outer core organizes itself in these huge vertical vortices that are parallel to the rotation axis of the Earth. But on top of that, you also have the radial flow. So you can have two sort of regimes of flow that coexist in the liquid core, and that would contribute to the separation of light elements or their preferential paths that they take in the liquid core as the solid inner core grows. And then, how these light elements are distributed in a 3D in the outer core is still an open question. And I think this study is a small step forward in this direction to understand what is the current distribution of light elements in the liquid core. And of course, why this is important. It's important because you can think of this distribution of light elements in the liquid core as the initial conditions for the geodynamo, because the convection in the liquid core that's largely driven by the light elements is generating and maintaining the magnetic field of the Earth.
You mentioned earlier that the liquid outer core is solidifying from the inner core outwards. Does it also solidify from the mantle downwards or not?
I think that's not the case. because what drives the solidification is the particular temperature pressure condition, right? And the melting curve of iron is driven by the temperature pressure conditions.
So it's the triple point.
Right.
How did you make this discovery?
We were studying the so-called CODA correlation wave field, and CODA correlation wave field has two parts to understand. So the first one is the CODA. I already talked about it. It means the late part of the waveforms. So similar to music, we call it coda. And the first part, correlation, is just a fancy term for the similarity between seismic waveforms. So you can think of this correlation wave field as an extension of a physical seismic wave field. So instead of looking at direct physical seismic wave field, we compare the waveforms on many pairs of seismic stations or seismic receivers around the world. And instead of the signals of the earthquakes, we look at the similarity of these signals. So the correlation wave field becomes a mathematical extension of the physical seismic wave field. And by looking at the similarity of the tiny signals, we actually have a more potent tool than the signals themselves, because two weak signals will probably not reveal themselves about the observational threshold. But when you compare them and when you measure their similarity, they will become above this observational threshold. And so by looking at the many pairs of these similarities of the waveforms many hours after large earthquakes, we discovered that the correlation wave field, which is again this mathematical wave field, looks different for the paths from the north to the south than from the east to the west. And we were basically then able to demonstrate through the waveform modeling that the only configuration in the liquid outer core that explains our observation is the existence of this low velocity equatorial torus in the top of the outer core.
Do you know how thick it is? How big the torus is?
We think that based on our results, it extends down to at least 300 or 400 kilometers below or beneath the core mantle boundary towards the center of the Earth. And in terms of the width, it's somewhere between minus 35 and plus 35 degrees latitude.
That's Professor Hudavia Tolzic from the Australian National University. And this is SpaceTime. Still to come, a new hypothesis about the origin of the Earth's moon. And Pluto's binary partner Charon reveals some of her secrets. All that and more still to come on SpaceTime. A new study has come up with a different hypothesis to explain the origin of the Earth's moon. Over 6 missions to the moon from 1969 to 1972, NASA's Apollo astronauts gathered more than 800 pounds of lunar rock and soils. Chemical and isotopic analysis of these materials showed that they were very similar to rocks and soils found on Earth, calcium-rich, basaltic, and dating to about 60 million years after the solar system was formed 4.6 billion years ago. And using that data, planetary scientists came up with a consensus that the moon was most likely formed after a Mars-sized planet, which has been dubbed Theia, collided with the early proto-Earth, turning both bodies into a massive magma ocean. That ocean eventually coalesced to form the Earth as we know it today. But some of the debris from the impact was ejected into space, eventually going into orbit around the newly created Earth and then accreting to form the moon. Now, this hypothesis is called the giant impact theory, and it answers most, if not all, of the questions scientists have about the moon's origins. But is that the true story of where the moon came from? A new study published in the Planetary Science Journal offers another possibility. That is, that the moon was captured during a close encounter between the young Earth and a separate terrestrial binary planetary system, which involved the moon and another rocky object. While the so-called giant impact theory set the narrative for the next 40 years, questions still remained. For example, a moon that forms from a planetary collision, taking shape as debris clumps together in a ring, should orbit above the planet's equator. But the Earth's moon orbits on a different plane. In fact, the moon's actually more in line with the sun on the ecliptic than what it is with the Earth's equator. Now, in this new alternative theory called binary exchange capture, the authors speculate that Earth's gravity separated a binary partner, the Moon and another terrestrial planet, snagging one of those objects, which we now call the Moon, and flinging its binary partner away to somewhere else. They say this new hypothesis would explain the Moon's orbit in its current plane. And they say there's evidence to support their hypothesis elsewhere in the solar system, with Triton, the largest of Neptune's moons, being a good example. The reading hypothesis for Triton is that it was pulled into orbit around Neptune from the Kuiper Belt, a place where 1 in every 10 objects is thought to be a binary. Pluto and its binary partner Charon being a good example. More about that later. The thing is, Triton orbits Neptune in a retrograde orbit, moving in the opposite direction to the planet's rotation, and its orbit is also significantly tilted, angled at 67 degrees to Neptune's equator. Now, according to this new theory, the Earth could have captured a satellite even larger than the Moon, an object the size of the planet Mercury, maybe even Mars. But the resulting orbit may not have been stable. Now, one of the study's authors is Darren Williams from Penn State University. He says the problem is that the capture orbit, the one that the Moon follows, began as an elongated ellipse rather than a circle. Over time, influenced by extreme tides, the shape of this orbit was changed. See, today the Earth's tide actually moves ahead of the Moon, and high tide accelerates the orbit. It gives it a sort of pulse, a bit of a boost. Now, over time, that boost is causing the Moon to move further and further away from the Earth. Every year, the Moon moves away from the Earth at a rate of 3 centimetres. Williams says the effect's reversed if the Moon's closer to the Earth, as it would have been immediately after capture. But by calculating tidal changes and the orbit's size and shape, Williams and colleagues determined that the Moon's initial elliptical orbit contracted over a timescale of thousands of years. And the orbit also became more circular, rounding its path until the lunar spin locked it into its orbit around the Earth as it is today. Williams says at that point the tidal evolution likely reversed and the Moon began to gradually drift away. And at its current distance from the Earth, 384,400 kilometres, the Moon now feels a significant tug from the Sun's gravity. Williams says the Moon's now so far away that both the Sun and Earth are competing for its attention. Both are gravitationally pulling on it. Williams claims that his calculations show that mathematically a binary exchange captured satellite could behave just as the Earth's Moon does. But he's not certain that's how the Moon came to be. He says no one knows for sure how the Moon was formed. The last 4 decades, science has had one possibility for how it got there, but now, Williams claims, he's opened up a treasure trove of new questions and opportunities for further study. The first of which, I'm sure, will be why the Moon's chemical composition is so similar to that of the Earth. This is SpaceTime. Still to come, Pluto's binary partner Charon reveals some of its secrets, and later in the science report, a new study looks at why Mount Everest is so tall. All that and more coming up on SpaceTime. A new study shows that Pluto's binary partner Charon has vast reserves of carbon dioxide and hydrogen peroxide on its surface. The findings, reported in the journal Nature Communications, are based on new observations by NASA's Webb Space Telescope. The carbon dioxide ice, also known as dry ice, appears to be a thin layer covering a subsurface mostly made up of water ice. It's thought the carbon dioxide was most likely stored beneath the surface of the frozen world until it was exposed by impact events, while the hydrogen peroxide could have formed from radiation breaking apart water ice. These new discoveries add to Charon's already known chemical inventory, previously identified by both space-based and ground-based observations. And it includes water ice, ammonia-bearing species, and the organic materials responsible for Charon's grey and red coloration. The study's lead author, Sylvia Protopapa from the Southwest Research Institute in San Antonio, Texas, says Charon's the only mid-sized Kuiper Belt object in the 100 to 1600 kilometre diameter range that's been geologically mapped. That's thanks to NASA's New Horizon mission, which flew past the Pluto-Charon binary system in 2015. Unlike many of the larger objects in the Kuiper Belt, the surface of Charon isn't obscured by highly volatile ices such as methane, and therefore provides valuable insights into how processes like sunlight exposure and cratering affect these distant worlds. In 2022 and 2023, the authors used NASA's Webb Space Telescope's near-infrared spectrometer to obtain 4 observations of the Charon-Pluto system. Different viewing geometries provided full coverage of Charon's northern hemisphere. The advanced observational capabilities of Webb allowed scientists to explore the scattered light from Charon's surface at longer wavelengths than would otherwise have been possible. And that expanded their understanding of the complexity of this fascinating world. The team compared their spectroscopic observations with laboratory measurements and detailed spectral models of the surface, concluding that the carbon dioxide is actually present there primarily as a surface veneer on a water ice-rich subsurface. Protopapas says the preferred interpretation is that the upper level of the carbon dioxide originates from the interior of this world and has been exposed to the surface through cratering events. Carbon dioxide is known to have been present in regions of the protoplanetary disk from which the Pluto system was formed. And the presence of hydrogen peroxide on the surface of Charon clearly indicates that the water ice-rich surface was altered by solar ultraviolet radiation and energetic particles in the solar wind and galactic cosmic rays. You see, hydrogen peroxide can be formed from oxygen and hydrogen atoms originating from the breakup of water ice due to incoming ions, electrons and photons. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study warns that people with type 2 diabetes who sleep for more than 9 hours a night or less than 7 hours a night are more likely to experience microvascular disease, which involves damage to small blood vessels and which could ultimately lead to more serious complications. The findings, reported at the annual meeting of the European Association for the Study of Diabetes, was based on research involving 396 people with diabetes who were categorised according to how long they slept. Among those who slept for less than 7 hours nightly, 38% had vascular damage, while among those who slept more than 9 hours, 31% also suffered the same damage. In the group who slept between 7 and 9 hours, the incidence was far lower, just 18%. The authors found the risk linked to short sleep was highest in people over the age of 62, but not for long sleep. They say interventions to help improve the health of diabetics could include a focus on improving sleep. A new study has suggested that Mount Everest has become taller than other Himalayan peaks, partly because of a nearby river system. A report in the journal Nature Geoscience claims researchers modelled how drainage piracy, that's where one river captures another, would have increased water flow in the Arun River, 75 kilometres from Mount Everest, accelerating local erosion. Today, the Arun River runs to the east of Mount Everest and merges downstream with a much larger Kosi River system. Over a millennia, the Arun has carved out a substantial gorge along its banks, in the process washing away billions of tons of earth and sediment. Now, in response to the loss of all that eroded material as the river gorge deepened, the ground underlying the wider area would have rebounded upwards, possibly by as much as 2 millimetres a year, and in the process that could have increased Mount Everest's height. In fact, the model suggests that between 15 and 50 metres of Mount Everest's height might be due to this river capture event, which probably took place about 89,000 years ago. At 8,849 metres, Mount Everest is the tallest mountain on Earth and rises about 250 metres above the next tallest peak in the Himalayas, K2. Everest is considered unusually high for this mountain range. That's because the next 3 tallest peaks only differ by about 120 metres in height from each other. A new study warns that higher temperatures and rainfall could increase the chances of urban lightning strikes. The findings, reported in the Journal of the Royal Society, analysed the geographic, climatic and urban variabilities of 349 cities worldwide to try and figure out why urbanisation often leads to increased local lightning frequencies. The authors found that cities with higher temperatures and more rainfall than their surrounding areas are also more likely to show lightning strike increases, especially in warmer and wetter regions and in cities with larger urban areas and nearer the equator. A couple of movie producers claim they've accidentally captured some footage of what they describe as a real live lake monster while they were filming a movie about, well, a lake monster. Tim Mendham from Australian Skeptic says the team have now lined up some apparent experts to evaluate what they've filmed.
Now, this is Lake Champlain, which is near the US-Canadian border. And it's a supposed lake monster which people have recognised and sort of claimed since about the 1800s. And for a while, it was the most famous lake monster in the world until that other one cropped up in Scotland. And the publicity machine for the Loch Ness monster was far better than the one for Lake Champlain creature that, it got swamped in a way. And then everyone's quite depressed that Champy, as it's called, wasn't getting as much notoriety as possible. There are still the diehards. There's a local little league baseball team called the Champs, and there is a Champ Festival and that sort of stuff. But if you ask people to name a lake monster, they'd all say Loch Ness straight away. So anyway, these couple of people wrote a book called Lucy and the Lake Monster. It's about a girl trying to prove that this monster does exist. The book was popular, so they made a film. It's really a kid's film in a way. And they were filming the girl and the father out in a boat, fictional girl and father out in a boat on the lake. And they were filming it from a drone. So they're looking straight down onto them in the boat. And when they got back and were looking at all the footage they'd filmed, which is quite a lot, they suddenly noticed this shape underneath the boat, moving apparently. And it's bigger than the boat, and so it's not this tiny little thing. And as they said, it was moving its arms with fins in the way that a plesiosaur would move. I don't know if they've ever seen one move, but they assumed they would move in a certain way. And so they thought they have actually captured footage of Champy in the flesh, in the water. Now, it is a shape underwater, so I don't know how clear it is. They haven't revealed the information yet. They haven't released the footage yet. They are having a world premiere of the film they've made at a small arts theatre in a small town in Canada near where Lake Champlain is, and then it's going to be shown a few other things. It's not exactly a Hollywood premiere. They say it's very exciting to see this thing. They do have a propensity to believe. One of the producers of this film said that they do believe in these sort of creatures. They gave this footage to, and I quote here, "We decided to have it evaluated by trained scientists with a minimum of one earned doctorate degree in real science." Having a doctorate degree doesn't guarantee you're going to be a good source of...
No, you can get a doctorate in breakdancing these days.
So we're getting these professors to look at them and to report back their findings. There have been photos of this thing done in the past. One famous one of it looking like it's on its side and turning its flipper up into the air. Or maybe that's its head. A bit hard to tell. There's some good stories about Lake Champlain and the search for evidence. What these two people who made the film say is that all the evidence we've seen so far doesn't have context. It's just this shape in the water. So they're very excited about this one because you get a comparison between the size of the boat and the size of this creature.
Certainly helps promote the film, doesn't it?
It does help, promote the film, yeah. So we're going to have to see the film before we'll wait for the film to be released before we can say anything further. We're going to have to take their word for it that it was a plesiosaur swimming underneath the boat.
That's Tim Mendham from Australian Skeptics. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.